Hi guys, Ian here. In this video, we are going to talk about vectors. But before we start talking about vectors, let's see what a point is. A point is a location or a position in space represented using x and y coordinates in a 3D or a 2D plane. Let's consider a 2D plane. We have x axis and we have y axis. So a point would look something like this, and we can represent it using x coordinates and y coordinates. Whereas a vector is a quantity which has both magnitude and direction, magnitude being size or length, and these vectors are represented using lowercase letters with an arrow on top. Now let's take the same example as we did in the previous video to describe or to define scalars. Say I have two houses, house 1 and house 2, and I travel a distance of 10 meters from house 1 to house 2 in 5 seconds. That means I travel a distance of 2 meters per second, and this is what we call speed. And speed is also a scalar quantity. Now if I say I travel 10 meters in 5 seconds from west to east or from left to right, now what we have here is we have magnitude and we also have direction. So this collectively is what we call vectors. So vectors contain not only magnitude, they also have direction. Now let's define vectors in terms of matrices. Now in terms of matrices, a vector is a matrix which has either one row or one column, and these vectors in terms of matrices can be represented using uppercase letters with an arrow on top. As you can see, we have an uppercase letter A which has an arrow on top, and then we have a vector here which has n number of elements and it has only one row. Likewise, we have another example here, vector B, which has only one column. As you can see, it has only one column and it has many number of rows. N number of rows, we could say. And this, in the first example, we had n number of columns and we had only one row. And in the second one, we have n rows and only one column. Now a matrix or a vector which has only one row is called a row vector. Now this row vector can have only one row, but it can have any number of columns. For example, we take vector A and we have only one row. We have to put only one row here. So we say A1, A2 up to AN. Now these are n number of elements in it, but it has only one row, and you can say it has n number of columns. On the other hand, a column vector is a vector which has only one column, but it can have any number of rows. For example, we have a vector B and it has n number of rows, B1, B2 up to Bn. Now as you can see in this vector, we have one column but we have n number of rows. So this is what a column vector is. Now let's see how we can represent a point in a 2D Cartesian plane. This here is a 2D Cartesian plane, and let's say we have a point here, and as you can see, the x coordinate of this point is 2 and the y coordinate of this point is 3, and this is how we can represent a point in a Cartesian plane using its x and y coordinates. Now if we were to find the distance between the origin and this point, then we could use a formula known as distance formula, which can be directly derived from the Pythagorean theorem. And the formula is something like this: distance equals square root of x square plus y square. Now if we were in a 3D plane and we had to calculate the distance of this point from the origin, then we could use the formula as something like this: x square plus y square plus z square. So it would be square root of x square plus y square plus z square. Then we would have a third point here, or a third component or a coordinate. Now this is how we can find the distance of this point from the origin. Now let's see how we can represent vectors. Now let's say I have a vector A and I wanted to find its distance from the origin. To do that, we could use the formula which is known as the distance formula, and it can be directly derived from the Pythagorean theorem. So distance of vector A is given by square root of x square plus y square. Now you could also write it as distance or magnitude or distance of vector A equals square root of x minus 0 square, since we are calculating the distance from the origin, so it would be plus y minus 0 square. And for 3D, if we had 3 components, then we could do plus z minus 0 square. Now we could also construct a triangle, and the magnitude of this A is given by the square root of x square plus y square, which is basically the sum of these squared sides. Now let's see if we can visualize a point in a 3D plane. As you can see, I have a 3D plane here with me, and let's say I have a point here at this location. Then what you would have to do is you would have to find its x component, its z component, and its y component, meaning 3 components, x, y, and z, and this will give you the position or the location of this point in a 3D plane. Now, if you wanted to find out the distance between any 2 points, then what you could do is, say we have 2 points, A and B, and if we wanted to find out the distance between these 2 points, then what we could do is we could use the distance formula, which can be directly derived from the Pythagorean theorem. So distance of A to B is given by square root of x2 minus x1 square plus y2 minus y1 square. Now the coordinates of this A point are, or point A are 1, 3. The x coordinate or x1 coordinate of this A point is 1, and the y coordinate is 3. Likewise for B, the x coordinate is 3 and the y coordinate is 2. Now you can calculate the distance between these 2 points. Distance of AB equals square root of, what is x2? x2 is 3. What is x1? 1. 3 minus 1 squared plus, what is y2? 2 minus 3 squared. Now you could do the calculation by yourself and get the result. Now this is how you can find out the distance between 2 points in a 2D or a 3D plane. This was all about vectors. I hope you liked this video. Make sure to like and subscribe to my channel and drop a comment below. I'll see you in the next one.